So, hello everyone. Thank you for coming to this presentation. NMOS, what's in it for me? I want to share my own personal experience, what's in it for me. Actually, about a year ago, I was standing here doing a presentation about how end devices should report a minimal set of alarms so people would be able to track down problems really quickly. And then we wrote a white paper and suddenly Anwar got interested and now we are talking about standardizing those alarms. So that's in it for me. But over this whole time I got to know a lot about NMOS, which I didn't know before. And I want to share what I learned, which probably other people also don't know yet. NMOS, let's say, in a different angle. So, but before I do that, I want to just introduce myself. Just one slide. We are running a company called Simplexity. We are based in Switzerland, in Zurich, so excuse my German accent, Swiss accent. What we do is basically consulting and training. We don't sell anything. We are not a system integrator. We just want to transfer knowledge and gain knowledge. And so we are doing all kinds of consulting on, troubleshooting level all the way to strategic discussion and so on, how to approach mainly audio, video, or IP. That's our specialty. So we have done a few 2110, or basically we're with a few 2110 installations and NMOS and stuff like that. So that's what we do. So let me start with what I believe is NMOS today. And I'm not gonna talk about technical stuff, I'm gonna talk about the situation NMOS is in today. I think there is applications in conjunction with 2110. And when people talk about NMOS, what they really mean is ISO 4 and ISO 5. And NMOS can do and specifies a lot beyond NMOS ISO 4 and 5. And that's unfortunately largely unknown to most people. On the audio side, AS67, there's quite a lot of people, even manufacturers, who are totally not aware about NMOS today. And I think another important aspect is that for many manufacturers, the business case of implementing NMOS is kind of unclear to them, and they are kind of hesitating to do it. And now that's the situation. So why am I doing this presentation? I want to address NMOS from a practical use case point of view, and I basically want to stay away from document numbers. Very unusual in this area. And I will mention a few of them, but that's not really the relevant point. It's about grouping the topics and find out what NMOS is about and what it can do for you, for me, for anyone else. So the intention of this presentation is really to address, first of all, users, end users, that they should hopefully push or ask manufacturers to implement more NMOS, because they are not going to do it unless you ask for it. The manufacturers, on the other hand, I want to basically convince that there is a business case about doing NMOS. So in order to achieve those two intentions, I'm going to go basically through NMOS and what it can do for you, for me, for everyone. And I'm going to start with some topics which show up in practical life when you do an IP installation. I just bring up a few. Topics of a typical installation in IP. I want to make a distinction between the development phase of a project and the operational phase of it. On the development side, you obviously need to do stuff like network design, you need to do PTP design, you need to think about control systems, how you want to do this, the workflows, all these kind of things. And once you've done all that and you're operational, then there's a whole lot of other things you need to take care of. For instance, then you start doing dynamic signal management. You want to start switching the signals between A and B. You have to configure correct stream formats again and again, unless you keep them static. But I mean, hey, we're doing IP because we want to be flexible, right? So these kind of things need to be set up correctly. And by the way, the conventional device settings, they are not going to go away. You still need to do multi-viewer setup, mic preamp control, and all this kind of stuff day by day, as you know. Then you need to monitor your installation. You need to know whether it's working fine. and you want to be able to find faults very quickly. And since we are doing IP and we want to start being flexible, what we also want to do, and we will do, is move or replace products. We want to move them around, let's say, in pools. We want to keep a number of devices in a pool and just take them out and connect them somewhere because that's where I need it right now today. And if you do that, then you need to discover where you just connected them, because otherwise they're invisible and not controllable. And what you also need to do is, obviously, you have to make sure that a new device, if something is replaced, gets the correct basic setup, the stuff you define, the default. So taking it out of the box to actually get it online can be quite a step. And last but not least, you need to constantly ensure that the security standards in your network are met. And there's no illegal stuff going on, and people may be doing stuff you don't want them to do. So if we look at that, on those scenarios and challenges and topics, question is, what can NMOS do for you in terms of what's defined in NMOS in these very practical situations? First of all, NMOS ISO 4 and ISO 5, which most people are familiar with, are actually taking care of exactly these two topics. And by the way, in the development phase, network design, PTP design, all that stuff, that's not for NMOS. It's not in focus for NMOS. You decide that stuff and you set it up once. But all the operational stuff, that's where it gets interesting. And NMOS right now, ISO 4, ISO 5, covers two of these lines. But I can tell you already now, at the end of this presentation, you're going to see that NMOS actually covers all the rest of it as well. There are clear specifications, and if they're unclear, they can be refined. But there's a meaningful work which has been done to define all those very practical use cases. So I'm going to go through them now, by the way, without mentioning the numbers. But I have done 4 groups of functionalities. And I'm going to use this kind of mind map illustration. NMOS does kind of a whole bunch of what I would call resource management. It basically manages whatever is there, devices, whatever. It takes care of signal management. It's a big topic by itself. It describes security aspects, and actually it can do device control and monitoring. So if I say it can do, it means it's specified how to do it. Obviously, it needs to be implemented. So let me look at resource management first of all. What does NMOS specify in terms of managing your resources? You're looking basically at your network with all the connected devices. Now, again, I want to stay with that mind map kind of illustration here. First of all, NMOS describes a central inventory system, more or less. And this inventory system is actually done in a way that it can really work across subnets and across the whole big infrastructure, which is a big difference to some of the other elements of addressing this. And it also considers redundancy and all this stuff. So it has been thought through for all of this. And you just need to read, and then it says how to do it. And that centralized inventory, basically, that contains, first of all, devices. And devices with their senders, IP senders and receivers. Okay, so you can find them in this inventory system. And actually, you can also read out by spec what a certain sender or receiver is able to do, which format it supports, and what you can connect to it, or what kind of format it is able to generate. And actually, it also is possible to look at which streams belong to each other. They call it natural grouping. You can furthermore annotate your inventory. You can basically give it a label, tags. You can basically put in any kind of descriptions. That's all very practical stuff you want to do in your inventory system. And actually, by the way, yes, it takes care of discovery. And everyone just talks about this discovery. They say, oh yeah, you need this NMOS because it manages your discovery. Yes, of course it does that. It basically has an automated mode to bring in your devices and their capabilities into a central inventory system. And funny enough, there is something else here in the resource management. It's actually also possible to read out the system-wide parameters you have decided to use. For instance, PTP domains and stuff like that. You can read that out, again, via a special mechanism. So that's the inventory part of NMOS. It's all there described. Now, let's move on to signal management. So the more dynamic part, let's say, in day-by-day operation. And for that, I want to use an illustration what I mean by signal management here. I just use an abstract, basically an abstraction of two AV devices, audio-video devices, and they may contain all kinds of stuff you potentially want to control. It may have some baseband inputs and outputs. It may have a matrix in there to switch between these inputs and outputs and maybe others, or into a sender or receiver. It may have GPIOs, it may generate metering data, thumbnails in the video side, all this kind of stuff. But also, obviously, in our context here, it contains an IP sender or an IP receiver, or both. So that's kind of the abstraction here. So when we talk about signal management, that's actually what I mean here. That NMOS basically is able to control those elements inside the AV devices and connect them to another device. So first of all, you know, it's very obvious, the senders to receivers. That's what everyone knows. Basically, you see that? No, you don't see my pointer. But anyways, the senders to receivers. But then, more than that, NMOS specifies also how you select baseband inputs and feed them into a sender. Or it also specifies in which baseband outputs a receiver should be fed. On a monogranularity of in audio channel use cases and so on. It also actually allows you to transfer GPIO, stuff like that. It's also clearly specified how to do that. So talking about tally and all these kind of things, or any other things. Metering, as I said. So it allows you to do all that. So this is kind of the scenario, what I mean by signal management. It means basically connecting all kinds of signals, if you want, from a sender to a receiver, or from one device to another. In detail, that's how the mind map for that looks like. So first of all, again, the basics. NMOS can connect pre-configured, in this case, senders to receivers. That's what everyone knows about. So that means you can assign multicast addresses. It's very, very important, because we should really reach the point where these multicast addresses are not statically typed into a device. NMOS actually describes clearly how to assign to a sender a certain multicast address. It can do it, it's clear, it's just a matter of the products doing it. Same thing actually is happening to enabling and disabling senders and receivers. Maybe you want to stop the packets coming out. You can do that with NMOS. And actually, I call it copy-paste a transport file, so an SDP file from a sender to a receiver. That's also what NMOS takes care of. But more than that, you can use any generic data source, for instance, a button press, or as I said, audio levels, which are just generating constantly changing values. And you can look at such a data source as a sender. And you can connect that sender to a receiver. And it will just transmit the constantly changing values almost as if it would be audio or video, but obviously in a much slower bandwidth consumption. So using this kind of functionality, there are people, they have implemented, for instance, generic control panels where button pushes are transmitted just from one source to a destination, and then they react to that button push. So that's perfectly possible. So that's also something you can do with NMOS. Then, as I said, you can actually control the baseband matrix, something a lot of people are not aware of. You can basically set a baseband matrix and say which channels you want in your senders and receivers. Then there is something very cool, stream compatibility management. It's actually a functionality which allows you to ask a sender, what can you do? What kind of stream formats do you support? And to ask a receiver, what kind of stream formats can you receive? And then as a control system, I may choose the perfect match. Now, obviously, you don't want to constantly change the sender format in a multicast environment, but it basically allows you to choose a certain stream format on a sender freely via a specified control command. So in a, let's say, more dynamic, not so much 24/7 operation, you may be able to do what the Pro AV guys want to do with HDMI. You know, just plug in, and then it adjusts, finds out what's the best resolution, and then actually, via this mechanism, a control system could switch the stream format accordingly, so the receiver can actually receive it in the best possible resolution or quality. So that's possible there. And by the way, stream formats, there is actually quite a selection being known in NMOS. It's not just 2110 and JPEG XS now, but it's also H.264, H.265, even NDI is now being kind of specified how you would do that. It's not quite finished there, but those are all topics which are in focus. So this is signal connections. All these topics are described in NMOS. Now let me move on to a very generic topic called device settings and monitoring. Now again, we have this model of some AV devices, and actually there's a part in NMOS which allows you to generically read, write, or whatever, any kind of settings of any device. I put that here in a kind of wider arrow here. It is basically an open generic layer where you can send and read and whatever, all kinds of settings. It's actually pretty cool. And it replaces, it could replace a lot of the, let's say, legacy kind of control protocols. For instance, Amber Plus or whatever. It basically does everything Amber Plus does, or AS70 or whatever. But also there is a clear specification, and that's kind of a little bit, I guess, very close to me, because I mentioned to you that I was bringing in the alarming and then a minimal set of reporting. So there is actually also a specification coming up what a sender or receiver should actually report if it's not feeling well or whatever, something. So the point in this case is, it's not about do you get access to information. It's about minimizing the number of information you're actually sending across the world. Less is more. Because nothing is more boring than looking at a screen with hundreds of messages. You need to reduce that. And if you need to reduce that outside of a certain device, then it's always work. And in many practical cases, that hasn't been done properly. And then people in the operating MCR, whatever, get just stormed with kind of messages, and they get used that it's actually not relevant or not true anyway, so they start ignoring it. And that's kind of a topic on that side. So let me look into the kind of aspects of device settings, a generic one. NMOS specifies a generic control protocol which actually defines a certain rule set of how to communicate with each other. It is basically open to define what they call device models. You can basically, as a manufacturer, you can model definitely all of your products and parts of it inside that spec. And any device models distinguishes between properties, so kind of settings. It allows to call up what they call methods, so it's kind of execute the functionality. I always use the example of hitting a play button on a machine. That would be a function call, a method. And actually allows notification, and that's a big thing. So you can, to a device supporting this, you can subscribe to certain elements which you are interested to know about. And if a certain value changes, a state changes, you would get actively notified from the network. So right now, as many systems out there, you need to poll, what they say poll, right? Basically always read out the value and then to find out now it has changed. That's not very efficient and doesn't scale very well across big installations. So NMOS describes that. And on the device monitoring side, which I just mentioned before, we are right now in the process of standardizing 4 alarms. And we believe these 4 alarms, they could save 80 to 90% of the problems. That means not saving it, but it could allow an operator to call the right person pretty quickly. And the 4 alarms we're going to standardize on is basically links, or parts of the links being down, packets being late or lost. Then PTP state, maybe suddenly, you lost your PTP, so you want to actually know about that. It's quite fundamental. And then finally, stream format mismatches of some sort, so invalid stream format. So we believe with these four alarms, if they are supported in every end device, you will find 80 to 90% of your problems. Circle them pretty quickly. There's a white paper, by the way, about this. If you're interested, write me. I'm happy to send it to you. Thank you. Someone has it with him. Cool. And as I said, these alarms are just a minimal set we want to standardize, and there is no restrictions for manufacturers to put in more, of course. Finally, there is an initial setup of device focus of parts of the NMOS. How do you take the box, the device out of the box, and how do you get it to a default setup? And there's actually, let's say, a backup restore kind of functionality, which is described, and actually is about to be described right now. So the fourth and kind of last topic there will be security. Security parts of NMOS, they describe the whole kind of standard mechanisms IT knows. And it basically says how to do, let's say, the whole encryption of commands using HTTPS, how to use an authentication server, and how to handle certificates and all this kind of stuff. So this is not news to IT, but it needs to be basically be described how to use that in the context of NMOS. So that's also there. So as an overview, and you don't need to read that slide because it's going to be far too small. This is what NMOS describes. It's basically everything. And now out of all of this, this is what people know about ISO 4 and ISO 5. And most of it is ready and clearly defined. So it's not like oh yeah, totally in the beginning. Some of it is under construction, but you can read it. You can. All the documents are public. Even the meeting notes are public. Every day updated. There's no restriction. Everyone can read everything. And if you now want to see the numbers for once, these are the numbers. So there's a whole jungle of documents, best common practices, IS, whatever. But yeah, that's where you can read and go and whatever. And I recommend starting with those, with that link on the top. And I don't think anyone will be offended if I say that right now the web page of AMWA is not quite the most efficient way, inviting. Thanks, Wes. Most inviting way to get into the details. So so that's maybe a good kind of entry point for you guys to look into it. So, as a user, what's in it for me on NMOS? I think NMOS can shorten your requirements engineering phase. You can just read what the NMOS guys have thought through, and maybe those people were not the most stupid on the planet, and maybe you have a question. Don't hesitate to shoot an email to that round. It's really not a problem. It's not an anonymous group of people of hundreds and thousands of names. It's actually you can get to know these people. And my experience is if you have a question and you shoot it into these, let's say Slack channels or whatever, you get actually answers within minutes mostly. These are very passionate people about what they're doing. So you can basically leverage work done by others and actually, use that work when you write your RFPs. Don't have to think it all through yourself. But please, don't just write in your RFP, it has to do NMOS. It's just not enough. So ultimately, it will help you building an open system which has less or no vendor lock-in, and it will lead ultimately to save cost for the end user. So my wish for the end users amongst you would be, please go to the vendors and ask them, can you do this? Yeah, you can do it. Can you do it with NMOS? Can you do it for us, please? And put that into your RFPs. And as a manufacturer, again, the same thing. It shortens your requirements engineering phase. If you are not okay with something, bring it up. Shoot it into the email and say, guys, why did you do this? I think it's nonsense. Okay, it's okay. Bring it up. Maybe it finds its way into the next revision. The other one is, again, you want to leverage work by others. Specification is one, coding, testing. There is actually sample code available for every single bit in there, including testing code for it. It's all there. So like that, you can become part of a complete solution rather than just products. And you don't have to do that all yourself. So get yourself known for being open-minded. And if things are not clear, please ask. It's really possible to get the answers pretty soon. And ultimately, again here, save cost, increase your profit. That's the business case. So that would be the last kind of the run through NMOS. And the question is, are there any questions?
Thanks, Stefan.